So, let's go. You're looking at the largest planet in the solar system. A storm bigger than Earth has been raging on its surface for at least 350 years. Nobody knows why it's red. That's just the first thing. Here are 10. Number 1, the red spot doesn't make sense. You've seen it. That dark orange bruise on Jupiter's face. It's a storm, technically an anticyclone, a spinning system of high pressure, and it has been going continuously since before the United States existed, maybe longer. Historical records show something in that spot as far back as 1672. Here's what makes it deeply strange. At its peak, this storm was 3 times the diameter of Earth. 3 Earths stacked side by side would fit inside it. Today it's shrunk to about 1.3 Earths wide. It's been shrinking for decades and nobody knows why or whether it will stop. The winds at the outer edge hit 300 to 400 miles per hour consistently for centuries. With nothing feeding them, no warm ocean beneath, no landmass to funnel air, no surface at all. Earth's hurricanes die in days when they lose their heat source. This thing has been running for longer than modern science has existed, but the color is what breaks people. Jupiter's atmosphere is made of ammonia, ammonium hydrosulfide, and water. All of them colorless. Completely, thoroughly colorless. Something is turning the great red spot red. And after decades of lab work and spacecraft flybys and every analytical tool humanity has aimed at it, nobody has confirmed what that something is. Leading suspects include organic compounds created when UV light from the sun reacts with ammonia and acetylene, possibly sulfur compounds altered by cosmic radiation. Nobody agrees. Nobody has proven it. And then Hubble caught something else. Between December 2023 and March 2024, it watched the storm closely enough to notice that the whole system speeds up and slows down on a 90-day cycle. It oscillates. Nobody predicted it. Nobody can explain it. There's also a real chance this isn't even the original storm. A feature called the permanent spot appeared in the 1600s, then vanished from records for 118 years. The Great Red Spot appeared afterward. 2 different storms, the same one in disguise. We don't know. If the current storm keeps shrinking, one of 2 things happens. It finds a new stable size and holds there, or it disappears. A feature that has outlasted every human civilization currently alive, gone. Number 2, the geometric storms. Nobody predicted. Here's the thing about Jupiter's poles. Nobody looked at them properly until 2016, when a spacecraft called Juno swung around and pointed its cameras straight down at the North Pole. What the scientists saw stopped them cold. Not one storm, not chaotic swirls. A single large cyclone at the center, surrounded by 8 more, each one roughly the size of the continental United States, arranged in a perfect octagon. Like a geometric pattern. Like something organized it. At the South Pole, the same thing. 5 cyclones forming a pentagon around a central storm. Then, in November 2019, a new storm appeared, about the size of Texas, and slid into the ring. Now it's a hexagon. These storms have held their formation for years, on a planet with no solid surface to pin anything down, with winds that should tear structures apart. They have stayed in position. On Earth, when 2 hurricanes get close enough, they spiral into each other and merge. These storms repel each other. There's a ring of opposite rotating wind between each one acting like a buffer. But why those buffers exist, why they hold, why the whole arrangement stays geometrically perfect, unknown. Saturn has 1 polar storm. 1. Jupiter has 9 at the north and 7 at the south. Planets of similar composition, similar size, completely different poles. A planetary scientist on the Juno team put it plainly. We never saw anything like this before. We never even predicted it. Current models of how atmospheres behave can't fully account for it. And it's been sitting there the whole time we've been watching, completely invisible from Earth, waiting for us to look. Number 3. The planet is hundreds of degrees too hot. Jupiter is 5 times farther from the sun than Earth. It receives less than 4% of the sunlight we get. You can work out what the temperature of its upper atmosphere should be. It should hover around negative 73 degrees Celsius. Cold, quiet, frozen. Instead, it's positive 426 degrees Celsius up there. That's not a rounding error. That is a 500-degree gap between what physics predicts and what's actually happening. Scientists called it Jupiter's energy crisis, and it went unsolved for 50 years. The best current answer: Jupiter's auroras. Unlike Earth's northern lights, which flicker when a solar storm hits, Jupiter's auroras are permanent. They never turn off. And they're not just powered by the sun. They're also fed by material blasted into space by Io, Jupiter's volcanic moon. The poles superheat to 725 degrees, and then Jupiter's own winds distribute that heat across the entire planet. In 2022, scientists actually watched it happen in real time. A compression in the solar wind struck Jupiter's magnetic field, supercharged the northern aurora, and launched a heat wave toward the equator. 130,000 kilometers long, 10 Earth diameters, 700 degrees, moving. But then the James Webb Space Telescope looked at the aurora in 2025 and found something that made the team go quiet. Bright aurora features in the infrared, features with no counterpart in ultraviolet at all, which is physically impossible under the current model. To produce what Webb saw, you'd need enormous quantities of very low energy particles hitting the atmosphere in a way that was previously considered impossible. The energy crisis might be solved, or the solution might have a hole in it nobody has found the bottom of yet. Number 4. It's raining helium through liquid metal. Forget the clouds. Go deeper. About 10,000 kilometers below Jupiter's cloud tops, you hit a pressure of 1 to 2 million times Earth's atmospheric pressure. At that depth, hydrogen doesn't behave like a gas anymore. It doesn't behave like a liquid in any conventional sense. It becomes a metallic fluid. It conducts electricity like a metal, but flows like a liquid. There's no word for this in everyday language because nothing on Earth's surface behaves this way. Now add helium. Helium, at those conditions, doesn't go metallic. It stays as a regular fluid. And metallic hydrogen and regular helium don't mix. Think oil and water. The helium forms droplets, and those droplets fall. It is literally raining inside Jupiter. Helium rain, falling through an ocean of liquid metal. This has been happening continuously for 4.5 billion years, and as those helium droplets fall, neon dissolves into them and gets dragged down too, which is how we know this is real. When NASA's Galileo probe descended into Jupiter's atmosphere in 1995, it found neon at 1/10 the expected concentration. The helium rain washed it out. Nobody has ever directly seen this happen. The rain layer starts at a depth 70 times deeper than the Galileo probe survived before it was crushed. Everything we know about it comes from the math, from models of what matter does under pressures and temperatures that don't exist anywhere humans have ever been. Jupiter is full of weather we will never see. Number 5, the lightning that shouldn't exist. Since Voyager flew past in 1979, we've known Jupiter has lightning. Massive bolts, far more powerful than anything on Earth, flickering through the deep cloud layers. The assumption was that it worked the same way as Earth lightning, ice crystals colliding in water clouds about 50 kilometers below the visible cloud tops. Juno flew close enough to look properly, and it found lightning in the wrong place entirely, 25 kilometers up, in clouds where it is far too cold for liquid water to exist. There should be no mechanism for lightning there. Water freezes solid at those temperatures, and ice can't do what water does to generate a charge. Except, if you introduce ammonia, something strange happens. Ammonia dissolves into water ice, and the mixture stays liquid down to negative 97 degrees Celsius. It's a natural antifreeze, and liquid ammonia water can generate lightning. Nobody predicted this. Nobody built it into any model of Jupiter's atmosphere. The same clouds produce what the scientists on the Juno team started calling mushballs, slushy hailstones, 2/3 water, 1/3 ammonia, that grow heavy and fall deep into the atmosphere, carrying ammonia and water far below where they should be. And this is where it connects to a different mystery. Jupiter's upper atmosphere had been mysteriously low on ammonia for decades. The Galileo probe's readings were dry, depleted, wrong. Turns out the ammonia isn't missing. It's just hiding, cloaked inside water, dragged deep by hailstones made of antifreeze, vanishing into the interior. The planet has been smuggling its own chemistry past every instrument we sent. Number 6. The magnetic anomaly that acts like a second South Pole. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's. Earth's field is simple, a tilted dipole like a bar magnet through the planet. Field lines exit the south, arc through space, return at the north. Jupiter's field is not like that at all. The field emerges from a broad section of the northern hemisphere, then returns at two separate points, the geographic South Pole and a second highly concentrated patch near the equator, nowhere near a pole. Just sitting there below the equator, dense and intense, a magnetic anomaly the Juno team started calling the Great Blue Spot. Not blue. That's just how magnetic south is color-coded on maps, but the name stuck. A Juno co-investigator described it directly. We don't know why that place has that kind of anomaly. The Great Blue Spot is drifting eastward at 4 centimeters per second. Slow enough that you'd never notice it in a human lifetime, fast enough that it will lap the entire planet in about 350 years. Juno watched it move. That makes Jupiter only the second world in history, after Earth, where we've confirmed that the magnetic field is actively changing over time. In 2024, a team looked more closely and found something underneath the anomaly, a jet. A fluctuation in the magnetic field that repeats on a 4-year cycle, possibly caused by waves moving through the metallic hydrogen deep in the interior. Possibly. Nobody is certain. The thing generating Jupiter's magnetic field, the mechanism, the dynamo, is sitting inside a substance that doesn't exist on Earth, behaving in ways we can model but not fully explain, being distorted by forces we can't directly measure. Number 7. The X-ray pulses that don't match. Jupiter fires X-rays from its poles. This was discovered in 1979, the same year Voyager flew past, and for 40 years nobody knew why. The mechanism was finally nailed down in 2021. Heavy ions, mostly oxygen and sulfur blasted into space by Io's volcanoes, get caught in Jupiter's magnetic field. Those field lines vibrate, like a plucked guitar string, and the ions surf those electromagnetic waves down toward the atmosphere. When they hit, they release X-rays. The North Pole pulses every 27 minutes like a signal, steady, rhythmic. The South Pole pulses every 11 minutes, and the two poles don't talk to each other. On Earth, the northern and southern auroras are mirror images. They're connected by the same magnetic field lines, so what happens on one side is reflected on the other. Jupiter's X-ray auroras appear to be completely decoupled. The north does its own thing. The south does its own thing. Each hotspot covers an area roughly equal to half of Earth's surface, and they pulse on different schedules with no correlation between them. The mechanism that creates them, mostly solved. The reason they act independently is completely unknown. Even the answers Jupiter gives you come with extra questions inside. Number 8. The oxygen hiding below the clouds. Here's how well we know Jupiter. After decades of flybys. After the Galileo probe descending into the atmosphere in 1995 and transmitting data until the pressure crushed it. After Juno spending years in close orbit. After every telescope on Earth and in space pointed at this planet. We still cannot directly measure what it is made of. Jupiter's oxygen is locked inside water. Water condenses and sinks below the visible cloud layer, and below those clouds no instrument we've built can reach. So, in 2026, a team built the most complete model of Jupiter's atmosphere yet attempted, combining atmospheric chemistry with fluid dynamics, and used carbon monoxide, which stays stable at high temperatures and doesn't condense, as a chemical stand-in for the oxygen that's hiding. What they found, Jupiter contains about 1.5 times more oxygen than the Sun. That settled a debate that had been running for decades. But the bigger finding was something else. The model showed that gas mixing inside Jupiter is 35 to 40 times slower than any previous model assumed. Where scientists expected hours, it takes weeks. The atmosphere is far more layered, far more still in the vertical direction than anyone thought. That slowness is why the water never rises. That's why the oxygen stays hidden. The planet has been sitting on its own composition, and we had the timescale completely wrong. 2 more missions are currently on their way to the Jovian system, Europa Clipper arriving in 2030, and JUICE arriving in 2031. Neither one is designed to answer this question directly. The clouds are still keeping their secret. Number 9. The core that breaks the textbook. Before Juno, the picture of Jupiter's interior looked something like this. A small, dense, solid core, maybe 10 to 15 Earth masses of rock and metal packed tight. Around that, layers of hydrogen getting less and less pressurized the further out you go. Neat. Ordered. The kind of structure that makes sense. Juno measured Jupiter's gravitational field in extraordinary detail on every close pass, and the picture that came back was nothing like that. The core is large, and it extends roughly half the radius of the planet outward, not the tight nugget anyone expected. And it has no clean boundary. The heavy elements are dissolved into the surrounding metallic hydrogen, blended outward, no sharp line between core and not core, like sugar that's been half stirred into water and left to sit. Scientists started calling it the fuzzy core, or the dilute core, which are scientific terms that essentially mean this is not what we expected and we're not entirely sure what it is. For a while, the leading explanation was a giant impact. Early in Jupiter's history, a planet-sized body carrying roughly half of Jupiter's core material slammed into the young planet with enough force to scramble its interior. In 2025, a team ran every version of this impact in simulation. Every angle, every mass, every velocity. The result was the same every time. The dense material settled back out and formed a sharp boundary. The opposite of what Juno found. The giant impact theory is out. The fuzzy core remains. Saturn has one too, by the way. Same structure. Same problem. 2 of the largest planets in the solar system with interiors that no current model of planetary formation can fully explain. The foundation of the biggest planet we can study closely is at the moment a mystery that the best physics we have cannot solve. Number 10. We only just found out when Jupiter was born. There are rocks sitting in museum display cases on Earth that witnessed the birth of Jupiter. They have been falling onto this planet for billions of years, picked up from deserts and collected from Antarctic ice, and for a very long time nobody knew what they were actually recording. Inside a type of meteorite called a chondrite, there are tiny glassy beads, between 1/10 of a millimeter and 2 millimeters across. Perfectly spherical, or close to it, they're called chondrules. They're the most abundant material in primitive meteorites. They formed 4.5 billion years ago, and for over a century, their origin was genuinely unknown. Rock that melted and then cooled rapidly in space, but what melted it? What cooled it that fast? In 2025, a team worked it out. When Jupiter grew rapidly early in the solar system's history, its gravity stirred up the orbits of nearby rocky and icy bodies and flung them into each other at enormous speeds. Many of those bodies contained water ice. On impact, the water vaporized instantly, coupled explosive steam bursting outward and shattering the surrounding molten rock into tiny droplets. Those droplets cooled in the vacuum and became chondrules. By matching the peak age of chondrule formation in meteorites to when Jupiter's growth would have caused peak collision rates, they got a date. Jupiter formed 1.8 million years after the solar system began. The solar system was less than 0.04% of its current age. Everything else, the inner planets, the asteroid belt, eventually Earth, came later. And the record of that moment has been sitting in museum drawers, embedded in rocks smaller than your fist, waiting for someone to ask the right question. That's what we're dealing with. A storm nobody can explain the color of. A geometric arrangement of hurricanes that defies atmospheric models. An energy crisis that got a solution with a hole in it. Helium raining through liquid metal in the dark. Lightning in clouds where lightning shouldn't be able to form. A magnetic second pole that nobody predicted. X-ray pulses from 2 poles that don't speak to each other. An interior full of oxygen we cannot directly measure. A core that broke every model built to explain it. Jupiter is the most studied planet in the outer solar system, and in 2026 we still can't tell you what's inside it, why it's the color it is, or how its core formed. It isn't a solved problem, it's the question.